Scale factors in 3D objects. So it says right here, opening paragraph, we've looked at the relationship between the scale factor and the area of 2D objects. Here we will look at the relationship between the scale factor and the surface area and volume of 3D objects. So we've done surface area, now we're working on volume. Okay, so let's look at this, and what we're going to start off with is comparing the surface area and volume of specific spheres. So we're told the radius of sphere A is 1, B is 3, and C is 5. Reminder, how we calculate surface area of a sphere, we use the formula 4 pi r squared. So all we're doing is substituting in our radius where the r is. If we put in a 1 for the first one, 1 squared is simply 1, so it simplifies to 4 pi. The second one, we have 4 pi and the 3 is squared, which is 9. 9 times 4 is 36, so this simplifies to 36 pi. The last one here, the 5 squared is 25. 25 times 4 is 100, so this simplifies to 100 pi. So we're going to do the same type of thing with volume. We have a different formula. It's 4/3 pi r cubed. You do not have to memorize these things. If you have a question like this on a test, you will be provided these formulas on your formula sheet. So substituting in 1 cubed is simply 1, so we get 4/3 pi. If we put in 3 cubed becomes 27. We simplify that as we multiply that to the 4/3. It becomes 36 pi. By coincidence, it's the same as the surface area. And the last one, if we multiply 5 to the power of 3, it becomes 125. It simplifies to simply a fraction. We could leave it at that. You could put it into a decimal if you wanted to, but let's just leave it at 500 over 3 times pi. So now what we're going to do is we're going to use these values to compare, well, first of all, scale factor. Scale factor is, if we compare B to A, simply 3 to 1, the scale factor is 3. C to A, 5 to 1, it is 5, and C to B is 5 to 3. And we'll just leave it at that. It doesn't get rounded up or down. Leave it in the form of a fraction. When we talk about surface area, again, we're comparing first B to A. So if we compare B to A, we use 36 pi over 4 pi. Remember, the pi's simply cancel out because there's one on the top, one on the bottom. We get 36 over 4, which simplifies to 9. And remember what we saw a couple of sections ago. What we're seeing here is the ratio of the surface areas is the scale factor squared. And we'll see the same phenomena on the next two. We put 100 pi over 4 pi. The pi's cancel out, simplifies to 25, and this is equal to the scale factor squared. And same thing for the last one. Simplified, 25 over 9. If we square root that, we get 5 over 3, or another way to say it, it's the scale factor squared, gives us 25 over 9. Okay, so we'll see something similar when we look at the ratio of volumes. So we're comparing again, B to A. 36 pi over 4/3 pi is equal to 27, which is 3 cubed. So what we're saying here, when we're dealing with volume, three-dimensional objects, what we're dealing with is the scale factor cubed. We should see the same thing as we move along, and you could do the math if you wanted to. It will simplify to 125, and 125 is 5 cubed, which is a scale factor cubed. And the very last one, again, this simplifies to 127 over 7, which is our scale factor cubed again. So, what's the relationship? The relationship between the scale factor and the ratio of the surface area of the two spheres, it is the scale factor squared. And when we talk about the relationship between the scale factor and volumes of two spheres, or volume of any kind of object, it will be this. In fact, the ratio of the volumes is the scale factor cubed. And we will go on to page 13.